Pre-calculus, example 3 for 9.3, more speed and direction. So we have an airplane on a course of 295 at 300 miles per hour. It encounters a wind blowing 30 miles per hour in the direction north 25 degrees east. Find the plane's actual course and speed. So we're looking for the resultant. So just like on the other problems, we have this relationship right here, and we're looking for the resultant. So this is how we will use our formula. So the V is going to represent the plane's original course, and of course W is going to represent the wind. So I'm going to start out by finding the velocity vector for the original course of the airplane and for the wind, and then I'm going to add those together to get my velocity vector for my resultant, then use that to find the speed and actual course. So this is going to be the direction. So the actual course and the speed. So again, just like on example 2, okay, where we had to find the speed and the direction, we're doing the exact same thing in this problem. All right, so for the original course of the airplane, I need to first find my direction angle. So I don't know why I drew this. Okay, so for the direction angle, I'm on a course of a true bearing of 295. I don't know why I'm out of control with these lines. All right. Sorry, kids. So my true bearing is 295. So that's going to go all the way through 3 quadrants and into the 4th one. Okay, so that's a 295 degrees. Okay, so that means that this little measure right here is 25 degrees. Okay, because this is 270 right here through 3 quadrants plus 25 would give me 295. So that means that this angle right here is going to be 90 minus 25, so that would be 65 degrees. All right, now we can find our direction angle. Remember that our direction angle starts positive x, goes counterclockwise to our vector, so it's going to be 90 degrees plus 65 right here, so that's going to be 155. So for my original course, I take the speed, 300 miles per hour, times the cosine of the direction angle, and 300 times the sine of the direction angle. And again, all calculator, we just type this in, 2 separate values. I get negative 271.9 and 126.8. Groovy. All right, now I'm going to do the exact same thing for the wind. All right, so again, I'm going to switch colors here. All right, so for the wind, I've got north 25 degrees east. Okay, so that means my direction angle for the wind now is going to start here and go counterclockwise to the vector. So 90 minus 25 is 65 degrees. So that is my direction angle. So for the wind, I'm going to have 30 miles an hour times the cosine of 65 and 30 miles an hour times the sine of 65. And when I do that in my calculator, I get 12.7 and 27.2. All right, now what I need to do is perform this right here to get my resultant. So I am going to switch colors again. So R equals V plus W, so that's negative 271.9, 126.8, plus 12.7, 27.2. So again, I'm going to add the horizontal components together. So negative 271.9 plus 12.7 results in negative 259.2. 126.5 plus 27.2 gives me 154. So now I'm going to use this to find the speed and the actual course of the airplane. So again, the speed is easy. It's just the square root of both values squared and added together. And when I type that into my calculator, what I get is 301.5, and that is in miles per hour. And now I am going to use my direction here, negative 259, so there's 259.2, and then positive 154. So there's my right triangle. I'm going to use tangent theta equals opposite over adjacent, and then tangent inverse in my calculator gives me theta equal to 30.7 degrees. That is not my direction. This is just the reference angle right here. Okay, so now what I have to do, I have to write it as a true bearing, or I have to write it as a north, however many degrees west. So if I write it this way, a directional bearing, I need to know this angle right here. Well, if I subtract 30.7 from 90, I get 59.3 degrees. So you can write your direction as north, 59.3 degrees west, or you can write it as a true bearing. Remember, that starts north and goes clockwise to the vector. So through 3 quadrants, 270 plus 30.7. So that's going to be 300 degrees, or 300.7 degrees, okay? So you can write it either way.